Matt, it's that microphone.
I don't think there's a microphone.
Yeah, there's no mic.
So I'll just talk about it.
Sure, it's not going to be quality, but...
You close the door.
Presenters are actually coming in. I'll wait for that. Oh, before the questions. I'll just say
But yeah, this is a much better.
Oh, yeah, I mean, I can.
Good morning, everyone. Welcome to the first presentation of the day. My name is Biscocho. I'm a software engineer on the search infrastructure team at Bloomberg. And today I'm going to be talking about modernizing metrics in Apache Solr. So before we get started, who is this talk for? So this presentation I'm going to show is basically our team's journey of the different problems and design decisions we came about trying to build a large-scale metrics collection pipeline around Solr, and how it eventually led us to completely redesigning how we collect and read metrics in Solr 10. So if you're someone who uses Solr today in Solr 9, and you want to see how it's going to start looking different in Solr 10, we're going to go over that later in this presentation. But even if you're someone in this room who doesn't use Solr, many of the concepts I'm going to be talking about, and the tools we talk about here, can be applied to any application. So this is a very generic kind of talking notes about Solr. And so with that, let's get started. So I work at a company called Bloomberg. We're the leading provider in financial news and data. Our main product is called the Bloomberg Terminal, and what it's able to do is gives financial professionals and our clients around the world real-time accurate data 24/7 so that they can make smart decisions on whatever their everyday work is. I work again on the search infrastructure team. So what we do is we offer Apache Solr as a managed service to engineers at the company so they can build search around whatever their application is. So with that, we'll talk about our platform. So we have a large scale on our platform. We manage thousands of Solr clouds with hundreds of millions of queries going to these clouds every day. So we have a very, very large footprint of search at Bloomberg, but managing something at this scale comes with a unique set of problems in that it can get very, very overwhelming to manage. So it's essential that we provide tooling for our team and our platform to monitor and alarm on things, on problems before they happen, as well as catching them after. But at the same time, those same tools need to give the engineers deep insight to make sure that Solr is performing to the level of their applications and their search application. So the question becomes, what does Solr offer for us to do that at this scale? Well, I would basically split Solr's observability tooling to three main categories you can see here. First, you have logs. That's backed by log4j, so that's just human readable text, standard in the industry, everyone knows. But in large distributed systems and the scale of thousands of clouds, we cannot just parse through millions of lines of logs across clouds. It's impossible. So then you have metrics. This is backed by a framework called Dropwizard with a way of getting in Prometheus. This gives you measurement of a service and events at runtime. You could do aggregations. It's a very powerful way of looking at your cloud in real time, as well as alarming on it. And then Solr offers distributed trace, backed by OpenTelemetry. So that lets you see the life cycle of a request from your application to Solr back as ways of debugging your application. So I would say these are the three main tools of observability Solr offers. But for the sake of most of this presentation, we're going to kind of focus on metrics and building a pipeline on that. But we're going to look at logs and trace lightly coming back later. So phase one of our team, at the very beginning, is how do we collect metrics from thousands of clouds with high cardinality and get it to our metrics backend. So this is the first phase of what we're trying to do here. So at the very base and minimum thing that Solr can do, you can hit an endpoint we just call the add metrics endpoint. That is the path that you can hit. Again, metrics in Solr is collected by this Java library called Dropwizard, just like an old Java library that you should collect metrics with. It's very simple. The thing is, when you hit this endpoint, you get this large JSON structure of metrics, structured by metric groups. We call it registries. You get a registry for every core. So if you look at the sample here, this is like a small snippet of it, but it has a hierarchy to it. So at the top, you have the name of your core, and then inside you have a JSON object in there, and that this specific snippet we're looking at is telling us the number of queries that actually went to that core. So you could get many more different metrics per core. And what's important is that this scales linearly with the number of cores. So the more cores you have, the more metrics you can get from this output, resulting in a very large response. So this is the base how you can get metrics, but Bloomberg, we do not read metrics or ingest them or aggregate them in JSON format. The modern way of looking at metrics is with attributes and labels like key-based data model, key value-based data model, so you can aggregate on them. So how can we do that? Well, Prometheus actually is that key-based model that we can do. So Solr ships with an external process called the Solr Prometheus exporter upstream. All you have to really know about this process is it's just an exporter, and it just scrapes that metrics endpoint we had just talked about, and it will transform it into Prometheus internally with JQ queries by parsing it with JQ queries. From there, you'll get your metrics with attributes and labels, that modern way of aggregating on your data on like Grafana and things like that. And then it just exposes an HTML endpoint, so now you just scrape the Prometheus exporter. Okay. So that's how you can get your metrics in Prometheus. But we're still not done on our infrastructure. We do not read Prometheus as our way at our company. We have our own format that's not Prometheus. It's still attributes and labels, but Solr won't have that. So how do we get there? We ended up using one last small piece of technology here. It's an open source metric agent called Telegraph. What you have to know about this, it's highly configurable with like a suite of plugins in that you can ingest metrics in many different ways. One of them being Prometheus. And then you can have a suite of plugins to export it to your backend of whatever it may be. But it's also customizable. You can create your own plugins for it. So we actually create our own plugin to go from Prometheus to our Bloomberg backend in our compatible way. And so that's it. That's all the pieces we needed to finish the first phase of just collecting metrics and spawn this first iteration. So this is like a very basic look. You can imagine here on the left thousands of clouds, but for simplicity, I'm going to show you. And so on a separate cluster, we spun up a Prometheus exporter for every Solr cloud, 1 to 1. So let's scrape that. You get drop wizard to Prometheus. And then on another cluster, we spun up Telegraph to then get Prometheus and move it into our metrics backend like that. And that's how we can kind of move our metrics in this pipeline. And it works. It's not perfect as a first iteration. There's many hops to get there, a lot of bridges, but it works. We get our metrics, attributes, and labels. So with that, when you have thousands of clouds, we can make cool dashboards like this. So with those labels on Grafana, we can see like who is the biggest in terms of throughput and ingestion on our clouds, or who's doing the number of queries, or we can alarm on who's using the most disk space on our hosts. And this is the power of attributes and labels. You can aggregate on like core level raw data, but you can bubble it up and like show it on a panel like at this level, at this scale. So again, this was our first iteration. It worked, but it wasn't perfect. The most prominent problem that we had run into was the Prometheus exporter and its memory. So what we had found is that we had some clouds with hundreds of cores. And if you remember what I said, the Prometheus exporter, it scrapes that admin metrics endpoint and it transforms it into Prometheus. But if you have a cloud with many cores, that results in like high cardinality, and some Prometheus exporter churning through, trying to parse out more and more metrics. And it was just leading to super high memory usage. So I was like curious, like what is the Prometheus exporter? What parts of it which is so inefficient? So I spun up a local Solr cloud on my laptop with 300 Solr cores, and then I profiled it with a JFR. What I had found is that over an hour and a half in the Prometheus exporter, cumulatively 600 gigs of memory was being allocated just trying to do JQ queries, that parsing of that admin metrics endpoint to transform it. So it was like super inefficient at what it was doing. And it was a very heavyweight process for us to just go from like this JSON format to Prometheus. So we figured, like looking at this pipeline, it kind of ended up spawning like the second phase. What can we do to improve on this? Now, Solr, the only way you can get your metrics with attributes and label right now at the time was Prometheus exporter, and you'd have to like go through this whole pipeline. But one of the ideas that I had thought of with the team and the open source community is, what if Solr just exposed these Prometheus directly? Like, we don't need this heavyweight process anymore. You can just let the user scrape directly from Solr. And so one of my first contributions to Solr was actually to do exactly that. I just get Prometheus metrics from Solr. And to show you how that would kind of look, here is a drop wizard metric in its string format and a base form. So this metric is just telling us the number of requests that went to this core. What's important with a drop wizard metric when we're looking here is that it's limited by dots. And you have this information in fixed positions in drop wizard. And they never move. So if you just parse those out strings, those are our labels. Those are the things we care about aggregating on in Grafana or whatever your backend is. So you can just very simply pull that out in a very simple string parsing way. And then once you pull that out, you can just form a Prometheus formatted metric, and you just append it that way. And that's it. That's how you just go from drop wizard to Prometheus, and I just written a bunch of code to kind of do that in a fixed way. And that's exactly what the Prometheus exporter was doing, just with JQ queries. But strings was doing string parsing was much more efficient. So after this actually did get contributed to Solr 9.7. So if you're a user of Solr 9.7 or higher, you can actually get your Prometheus metrics directly from their Solr clouds. You don't need to run the Prometheus exporter. You can just scrape directly on the admin metrics. Now the reason this was a big deal on our team is because we went from this first iteration, and after finishing this second phase, it spawned the second iteration. So basically what we were able to do is we were able to completely decommission 1,000 of those Prometheus exporters, because we had thousands of clouds, and get rid of and save us tons of resources of that whole cluster of VMs that were just running these Prometheus exporters. And so it just like streamlined our metrics pipeline significantly, just one-to-one. And so the maintenance costs was significantly reduced on our team. And it was important that this was stable because we alarm on these metrics. So like if a Prometheus exporter died, like it would be very difficult for us to have insight in what's going on. And so this was a big win on our team, just doing this small contribution. But even though it was a big win, what I had learned from doing this whole process of going to droplet into Prometheus is that I didn't actually solve Solr's problem in this contribution. And this contribution kind of exposed that. If we look back at the main problem we're trying to solve, we're just trying to get metrics from Solr to our metrics backend. And the only thing Solr had done as a project is created a bunch of bridges and exporters as ways to going from one framework to another. And all I did was I moved an exporter directly into Solr itself. So if we actually look at the root of Solr's problem, it was actually the framework, and that Solr's metrics framework is actually outdated, and it's fallen behind. And to give you a timeline of what I mean by when it's outdated, this is like Solr's observability timeline over the years. So back in 2016, that was when Solr was first instrumented with metrics with Drop Wizard. You can get metrics on the admin metrics endpoints, like Solr 6, Solr 7. And then 2 years later, the Prometheus exporter was contributed to the project. So you can get Prometheus metrics, which is a popular way of getting your attributes and labels. And then you didn't have to completely re-instrument Solr itself to get Prometheus. You just have to go run this external process. And then we come to last year, 2024. That's when I made my contribution, so you can get Prometheus metrics directly from Solr. But we're still using the same framework back in 2016, so still nothing has really changed. We're just doing a new bridge. And then we come to today, and this is like a 9-year span you're seeing here, and within 9 years, observability and tooling and the different formats of ways you look at metrics, especially with the popularity of attributes and labels for aggregating them, it's exploded tremendously. And Solr is still using the same framework that was given to it back in 2016, with only bridges to getting to these attributes and labels. So Solr has never really kept up in terms of its observability because it's been held back by Drop Wizard. So with this kind of ended up spawning phase 3 of this, which is to completely overhaul Solr and actually fix the main problem in Solr. So the question basically became, what are we going to use for Solr to avoid this problem in the future? Well, the framework that we decided with the community was OpenTelemetry. So if anyone here doesn't know what OpenTelemetry is, it's an open source observability project from the Cloud Native Computing Foundation. And in 2024 of last year, it was their second fastest growing project. And in 2023, it was their fastest growing project. And the reason this project is so popular among the open source community and the industry, there's been a very noticeable trend that the industry is going to using this, is because the whole mission of this project and its vision is to actually solve the exact problem that we had run into, and that Solr was dictating the user on how they get their metrics to their backend. And so it's trying to get away from applications being observability vendor specific or creating so many different exporters specific to Solr or your application. So it wants to make everything as vendor neutral as possible and standardize your telemetry collection. And even though I've just been talking about metrics here, this also goes for logs and traces. Standardize your collection of logs and traces as well, so things work seamlessly. And so one of the big ways it tries to be as vendor neutral as possible is with a thing called OTLP. Yeah. OTLP, it's a vendor neutral protocol, an open standard protocol, as a way to send your observability data to any vendor you want. it's like widely accepted among open source tools all the way to commercial tooling and vendors as a way to send your data there, since it's not specific to any one vendor. And it's become the native default way of sending your OpenTelemetry metrics, logs, and traces through one format, OTLP. OpenTelemetry has like a list of very popular tooling. So if you're using very popular tooling, it most likely accepts OTLP. And then the last thing I want to say that OpenTelemetry offers for a project is it's trying to unify observability. Unify your metrics, logs, and traces, giving you one cohesive, unified view of how you debug your application code. And to show you what I mean by this unified observability that OpenTelemetry is going to do, here is how Solr currently uses observability today. So you have logs, metrics, and traces. You push them in 3 different ways through 3 different formats and exporters, whatever, but then you push it to your preferred backend. Maybe there's additional bridges there, but you get them all back there. Now what's important to notice here is that you have 3 signals of observability. You use all 3 of these things to debug your application and monitor it and alarm on it, whatever, logs, metrics, and traces. But all of this data is siloed in a way in your backend that you can never see the full picture without having to context switch to piece everything together. It can make very things difficult, even though you use all 3 of these things to monitor your application. So the idea with OpenTelemetry is supposed to look like this. I think the long-term principle. We would instrument Solr with OpenTelemetry under one unified framework, logs, metrics, and traces. Then it gets enriched at this level with context, additional metadata, things that can make it better. There's additional signals that OpenTelemetry can also do in terms of enrichment. But from there, the user can use OTLP, that vendor-agnostic framework, to push it through a single pipeline instead of 3 separate exporters if they don't have to anymore. Through something like the OTel collector. I'll explain what the OTel collector is later, but they can push it through a single pipeline this way. And then from there, you push it to your backend, and since it was enriched all under the same umbrella of OpenTelemetry, instead of having to context switch and piece everything together, you get one correlated view, a unified view that you can connect the dots very easily to root cause analysis on all 3 of these signals together. And I think this is a very powerful thing that OpenTelemetry will offer in terms of observability for Solr, making it really easy to correlate all of your signals. So I'd say this is the long-term vision of what Solr should be with OpenTelemetry going forward. But with that ended up spawning the creation of SIP 23 with switch from DropWizard to OpenTelemetry for phase 3. So this is a big change coming to Solr 10. It's going to completely change the way you read metrics in Solr 10, as well as you collect them. So there's 4 main things I want to point out with changes. It's API breaking changes. But the first main thing I want to say at this first point is that all metrics now are just natively going to have attributes and labels. It's going to have that popular data model so that you can aggregate on your metrics. No longer this JSON format limited by dots. You have attributes and labels, gives you aggregation, no more explanations. The next thing is that the admin metrics endpoint that we were talking about earlier, the JSON, it's going to default to Prometheus and open metrics format. I'll explain what open metrics is later, but just know that Solr will still offer pull model support if you want to scrape for Prometheus metrics directly from your Solr nodes, which you can do in Solr 9.7, which is still a popular way, so we're going to keep that in place. Now, if this user doesn't use Prometheus, we're going to offer OTLP. So that is that vendor-neutral format so that you can push your metrics in a vendor-neutral way to whatever your backend is. So now Solr has this push model support that isn't specific to any vendor. So I would highly recommend users use that, probably over even Prometheus if you're spending a little. And then the last thing we're going to be doing for Solr 10 is completely removing the Prometheus exporter and its metric reporters from the project, slim down Solr, the maintenance it has to do in the project for it. And instead, we're just going to direct users to use external tools as ways of collecting your metrics. The Prometheus exporter was very specific to Solr. There was other tools that basically did what the Prometheus exporter did, but better. So there was no reason for us to reinvent the wheel. So with this first phase, what are we going to direct users to use instead of the Prometheus exporter? Well, I would say you should use the OpenTelemetry collector. So what is this? So the OpenTelemetry collector comes from the OpenTelemetry project. It's the standalone service, so you can still decouple your metrics pipeline from Solr. And it works seamlessly with OTLP, the new push exporter that Solr is going to have. but it's able to not just take in metrics, it's also able to take logs and traces as well, metrics, logs, and traces. And it's this vendor-agnostic service that you would run separately, and it lets you choose where you want to send your telemetry data without having to re-instrument Solr to vendor-specific ones. It has like a suite of different plugins from tooling to other vendors. It can do, you can fan out to multiple, you can even push multiple Solr clouds in its telemetry through one pipeline. It scales incredibly well. And it even does even more than that. You can do enrichment at this level, filtering of your data, batching retries. Maybe if you're doing migration or you want to test two different databases, time series data, you can send to both and test both. It helps you move and migrate. It's a very powerful tool that I highly recommend. If you're using metrics for Solr 10, you use this as a way to future-proof yourself, and it helps future-proof Solr. So this is something I highly recommend for Solr 10. Yeah. Now, continuing on, we're going to do more migration for Solr 10 in terms of the way we record metrics now. So the way you record metrics in Solr is with something called instruments and drop-wizard nomenclature. All you have to know about instruments is they're just the metric tooling so that you record your metrics in different ways and types. They're just the data types that you record your metrics. So two basic ones you've probably seen if you ever looked at Solr metrics was a counter and a gauge. So a counter is just a simple increasing integer, like over the lifetime of Solr. And a gauge is just a current instantaneous value. So like a counter, if you've seen like the number of requests that went to Solr, that's a counter. Then a gauge, like if you looked up something like the number of documents in a core, that was a gauge, like that can go up. So it's cool when we do this migration for Solr 10, it just goes to counter and gauge. Like they support it as well. So if you're used to seeing your metrics in that way, or you aggregate it in your backend, nothing changes in that regard. So that's easy. What does change though in this migration is what's after this. So the first big one is a meter. So Solr supported this instrument called a meter. It would give you rates, means, and moving averages over certain windows. So you can have like request rates over a 1 minute window and a 5 minute window. And then you get like some means and whatever. Well, OpenTelemetry doesn't support a meter. So when we do this migration, we're actually going to be moving it to a counter, that increasing number. And now you have to compute your rates in your backend. Now, there's a few reasons OpenTelemetry does this and why it's good for Solr. The first reason is that you can still calculate all of these things in your backend. And the other, yeah, you can still calculate this in your backend, and it also gives the user downstream better windows or more flexibility of how they want to get their windows. Because Solr would only give you 1 minute rate, 5 minute rate, but maybe the user didn't care about that window. They wanted like within the hour or something. Well, now you just have them to compute in their backend. The second reason is that it makes Solr's telemetry collection much lighter. Instead of having to do this computation, whatever, Solr should just be as simple as possible, giving you raw data so that you can collect your telemetry collection. So that's how we go meter to counter, so that's going to be different. Next up was histograms and timers. So a timer in drop-wizard was just basically a histogram built into it. This would give you a distribution of values. It was used a lot for latency. Big one was quantiles, so maybe you want to see like your P99 latency, P95. So when we move this to OpenTelemetry, it actually already supports a histogram with a counter built into the histogram. This gives you a distribution of bucketed values. So if you record like a latency value for Solr, like a bucket could be the number of requests that took less than 100 milliseconds. Now someone might still want, again, the mean, min, max quantiles. Well, you could actually still calculate your quantiles from this histogram of bucketed values. If you're used to something like Prometheus query language, it has a function called histogram quantile, making it very easy. So you can still get your P99 and P95. So this is how we're moving the metrics and how you should start reading them in Solr. So continuing with the migration, I want to talk more about what's going to be changing in Solr going forward, how we're going to future-proof its design. But to understand that and the way the user can use it, you need to understand how Solr was originally using drop-wizard before. So the way Solr designed metric collection was originally in 3 main components. The first one was metric producers. These are the things that were using those instruments that we talked about in the beginning. They're the ones that were collecting metrics. Now this would collect a bunch of metrics and these would go somewhere. it would go to this middle component called metric manager. So it's where it stored those registries, those metric groups, and you get a registry for every core. So all of those metrics just go into this one bucket in metric manager. Now, once you get these metrics, you want to get them out of Solr, aggregate them on your backend, whatever. So the way to do that is another component I would call metric consumers. These are the ways that you can consume your metrics out of Solr. So you have that metrics endpoint that we had talked about, and a Prometheus folder, which was my contribution to get Prometheus metrics. So with that consumer, a user can come in and be like, okay, I want to get JSON metrics or Prometheus metrics, or you can go through the Prometheus Explorer to get your metrics. The other way you could have got your metrics out of Solr was with a thing called metric importers. And Solr supported 3, JMX, GraphI, SLN, or J. So this was the main way how Solr would collect metrics and you would get it out. Now there's a few important things I want to point out in this design that are problematic. So the first thing is that here on the left, you have drop wizard instrumentation with no attributes and labels natively. It's not modern. It's in the structure of limited dots. It's in the string format. They made it very difficult to aggregate. Because of that, you have these set of things on the right that were tightly coupled to the instrumentation of drop wizard on the left. And that it was so brittle, if you changed even like the positions of the naming, you break everything in your consumers. You break Prometheus and all that. And the other thing is that you're locked to these set consumers of a user of Solr. So if you're someone who's trying to collect metrics from Solr and you don't use Prometheus, or these 3 metric reporters, you had to create an additional bridge outside of this to get to your backend. And it was annoying. And so this was problematic with drop wizard in Solr. So this is how we're going to change it in Solr 10 and make it better. And help future-proof Solr going forward so we don't have to go into this problem. So 2 things stay the same. Metric producers, now it's just instrumented with OpenTelemetry with attributes, those labels and tags. So that stays. Then in metric manager, you're still going to have registries, those metric groups per every core. So all those metrics still go into there, just instrumented with OpenTelemetry. Now the first new component we're going to introduce into Solr is this thing called OpenTelemetry metric readers. So this is a component in the OpenTelemetry framework in which you can read your metrics from these registries in a loosely coupled way in some different format. One of the ones we're using is Prometheus metric reader, so we get Prometheus metrics. So from there, the user can just, we can push that to the first metric consumer, the add the metrics endpoint. And so that's how we're getting Prometheus metrics out of Solr as metric consumer. Then you can go to your Prometheus supported backend. Then if someone doesn't use Prometheus, we're introducing another component. It's called the OpenTelemetry metric exporters. These are a set of components from OpenTelemetry that let you push your metrics. The main thing we're using there is OTLP, that vendor agnostic protocol to push your metrics out of Solr. And so they can go directly to the preferred backend if they want to tightly couple it, or they go through the OTO collectors. Now this is what's cool about this design that was, I think, better than what happened to drop wizard. So first here on the left, you have OpenTelemetry instrumentation. It's a non-vendor specific framework, OpenTelemetry with attributes and labels natively. And the idea is we shouldn't really have to re-instrument this left side again unless something drastic changes in the way we look at metrics, like it's not attributes and labels. From there, we have an interchangeable set of components here on the right that we can always future-proof Solr going forward. So we didn't, even though we're exposing Prometheus from Solr, we didn't instrument Prometheus. We instrumented OpenTelemetry under the hood. So we can change the metric reader from Prometheus if something new comes up, and OpenTelemetry comes up with a new format. We can add additional ones, we can change it. So that's a very changeable component there. And then even at the metric exporter level, we can change that and add push metrics and maybe some different vendor-specific way to push your metrics to your backend. OTLP will probably stay for a while. But then even then, if we don't want to ever change the way Solr read metric readers or metric exporters, the user has the way that they can use the OpenTelemetry collector, which has hundreds of plugins to get to your preferred backend this way, and all the tooling. So what's cool here is that going forward, we're not dictating how the user gets their metrics to their backend. They shouldn't need so many vendor-specific exporters to get your metrics out of Solr. And so I think this is a cool design, really keeping Solr future-proof for past Solr. Now I want to show what this can do, this design. So here's a very basic way that you can push your metrics out of Solr. You can actually do this in Solr 9. You can continue to do it in 10 if you want, if you really want. So you can pull metrics on the add metric endpoint to Prometheus, and then push your traces to the OTel collector. So you can do this, and continue to do this in 10 if this is how you do it. But you don't have to do this anymore. You do something like this. Like let's say you have multiple Solr files. Since Solr supports OTLP for metrics now, you can push them all through a single pipeline through the OTel collector. And then from there, use this plugins to go whatever backend you want. I'm showing Prometheus for Font and Tempo, but there's plugins for Jaeger or some other vendor-specific ones to get to your backend this time. But maybe you don't even want to use the OTel collector. You can tightly couple your pipeline as well. Just go directly to your backend. No need for hops. You can tightly couple it this way. So there's many different options you have going forward to sending your metrics in Solr 10 and reading them and all that. So these are the big changes, I think, of the design of Solr going forward with that. Now there's one last piece of tool I want to talk about for Solr 10 that's going to be offered. And it goes back to that unified observability thing I was talking about. And it's this tool called OpenMetrics. This is going to be available in Solr 10. And all you have to know about OpenMetrics is that it's an extension of the Prometheus exposition format. You're used to the way Prometheus looks in terms of its metrics. But it offers one piece of additional metadata called exemplars. So if you look on this bottom here on the left side of that curly brace, that's the standard Prometheus metric if you're used to reading that. But then in this middle part, you have this thing called an exemplar marker. That's that additional metadata in OpenMetrics. What this is telling us is a distributed request had come into Solr, and it had recorded a metric, and you sampled that trace. And so if you want to see what exactly that trace had done that recorded that metric, you can copy that trace ID and look it in your tracing backend. So let's say this was a metric of, you saw that an exemplar had recorded a request latency that took more than, I don't know, like 5-10 seconds, which is too slow for you. You can look at that trace ID to correlate exactly where it is instead of trying to dig through all your traces. So you're unifying your traces and your metrics as one view, which is really cool that we've done. So this is going to be available on the add metrics endpoint, but OTLP also will honor exemplars if you want to push that as well. And I'm talking about metrics and traces here, but this also applies to logs. So Solr 9 does this, and Solr 10 will continue to do this. But if you have distributed trace on in Solr, Solr will append the trace ID to all your logs and even propagate it across the nodes in this way. So you can now even follow your exemplars and your traces and your logs all in one unified view instead of trying to context switch and find everything as one thing, which is what Solr 9 you had to do before. So I think this is a really cool tool that Solr 10 is offering going forward as a way to unify the view of your cloud. And so that's kind of all the changes there. If you're interested in seeing all the changes, this is the Jira of all the code changes that's been going in for Solr 10. And I want to do a thank you to David Smiley. He's been a bit advocator in helping push and do the code reviews for getting this into Solr 10 as well, and some of the design decisions. That's it. Thank you.
Switching from the Prometheus exporter to Solr 9.7 to the Prometheus endpoint on metrics API, and then now being instrumented through telemetry, does the Prometheus format change between the three different ways that
Like the way it was seen in Prometheus exporter directly from Solr? Yeah, it's changing. We have some label names, the metric names are changing. So you will have to change like your backend. But if you scrape it from it, it shouldn't be too bad, but yeah, you have to change like your where you compute it or if you do any aggregation on that level, yeah.
and it will change in Solr 10 as well?
The way that the metric names are written? Yeah, that changes in Solr.
So you mentioned that there are certain things which that admin metrics traditionally used to give, like the P99, P95, and mean, median, and all of those stats, and which will now be given in the form of raw data and will need to be calculated as per the new in the new format, correct?
Yeah.
So is there a way? I mean, as a user, it could come across as a feature being taken away because those are pretty valuable metrics. I'm trying to think if it's possible to to calculate those and still retain those data points before you project the metrics? Is that a reasonable enhancement?
So you're saying you don't want to calculate in your backend. You want Solr to actually.
Yeah, the
sum
way
up
it
it.
always used to give.
Yeah, I mean, so OpenTelemetry doesn't recommend you do that. It recommends you do it to your backend because Solr should just be doing like raw calculations of your data. It should be light when it gets it. If you really wanted to do that, you should do it at the OpenTelemetry collector, which you can calculate it there. But there can be some histograms. Like imagine you have tons of cores, and imagine all these cores are calculating all of that telemetry collection. And this was actually shown. So there was performance. OpenTelemetry had a performance article that I had written comparing OpenTelemetry to Micrometer and Prometheus. Micrometer and Prometheus calculated histogram quantiles, as like you're saying, and OpenTelemetry had significantly less memory allocation because of that. It really saved it, and I don't know how big it was, but that's why I would probably recommend you still doing it backend. If we wanted to, we would have to write in our own P99 whatever, and like windows too. You have to like set the window of your P99. It could be kind of messy.
Can I ask if what you're really asking is if you have a simple setup right now where you're just looking at the raw metrics,
Right.
this change means that you now need to introduce a new product that you didn't have before.
Right. I mean, so for us, the way we consume the admin metrics is we don't use a Prometheus exporter. We just have an in-house dashboard which directly pulls from admin metrics, reads the stacks, and uses those directly. So that's where things like those will need to change, and plus and the format since it's changing. So there is some change on the reader side. I was just trying to understand the changes that the readers will need to make.
Right, so you have what I would call a simple backend,
Yeah.
and he was expecting you'd have a complicated backend. So sorry, you're going to have to put something new in
Yeah,
there.
you
Right?
have to probably do something. Yeah.
Is that true though for, if you're still in histogram, you're still in histogram, so we're still computing most of the stuff.
I'm sorry.
If for histogram, you're still computing everything the same. The only one that was explicitly changing from a meter to a counter were your 1 minute mean, your 1 minute averages, and 5 minute averages, right? So
In histogram, it wouldn't give you rates. It gave you like literal P99 or P95 over a small window, or whatever. There was different ways the histogram was calculated. I didn't write them all because there was a bunch. I don't remember which ones. But it is different, and you have to do it in your backend.
So you talked earlier on about the relationship between Prometheus exporter to Solr Cloud is kind of one-to-one. You need an exporter for each Solr Cloud.
Yeah.
What is the relationship between hotel collectors and Solr Cloud? Are you able to use much less hardware?
With the auto collectors?
Yeah.
Yeah, so the problem with the Prometheus exporter was doing a very specific JSON to Prometheus format. Hotel collectors, also the Prometheus exporter had like a link to Zookeeper, which was really annoying too. Hotel collector doesn't care about any of that, and it's going from attribute, like hotel attributes to Prometheus, which is also attributes. So it's much cheaper to move that, and the hotel collector, you can like put like load balancers in front of it, and it can scale incredibly, like much better. And it also does logs and traces as well. So yeah, it's just not specific. I think. Yeah, sorry.
Do you envision doing something like structured logs for
I'm sorry?
login? Do you envision doing something like structured logs?
Structured logs? I haven't gotten too much into logs yet, so I'm not sure what the changes for logs. That was like probably the next thing if we finish this one once this metrics. But yeah, improving on logging.
Does any part of it is any part of it like specific to Solr Cloud, or would it work with standalone as well?
Is what specific to Solr?
I mean,
Like
the
that,
way the
yeah.
metrics are, or say the admin metrics endpoint, right, or any of these collection tools, they're not tied. Are they tightly? I mean, do you need Solr Cloud, or will they work in standalone mode?
Oh, they
as
work
well?
in standalone. Yeah, yeah. This all work in standalone. You can set it up all. Yeah, yeah.
Would you mind backing up a few slides? You had sort of the final, that one, yes. Before Solr 10, essentially all the metrics were pull only, and so you've moved to a push model.
Yeah.
What happens on the Solr nodes when the hotel collector experiences downtime? Does those things queue up on Solr, or do you lose events?
Does OTLP? I think Solr just fails. Solr every time Solr does a push, it has like a thing. There's another reader in there called a periodic reader. So every 60 seconds, it's gonna take a snapshot of what the state is and try to push it to OTLP. It won't batch the states or whatever. So if it fails, you're just not gonna get your state to your backend.
Okay, so you'll just lose data.
Yeah, you lose that you lose that window of time. That's it. But like that's why you can run this in like a high availability way, run multiple, and then like I would probably recommend like you run multiple, put a load balancer in front of it, since this thing is stateless, so you can just go to any and then just route to your backend. To try to avoid that. But yeah, you'll just lose that window.
Okay.
How far are we from getting it all done?
I'm sorry.
How far are we from getting it all done?
We're mostly at the end. There's like a few other things, and we're just ripping out.
Because this is a blocker for Solr 10.
Yes. But we're at the ending stage.
I think you said there are 3 components to convert, plus the node value.
Yeah, which are no value thing.
Right.
And then.
And lots of us have been working on it simultaneously.
Yeah.
So we're getting there, right?
We're very close. Yeah, we're very close.
Full speed ahead.
Okay.
Yeah.
After you had
I've never seen so much collaboration on a single topic in such a short period of time.
That's good. Great. Out of time? Okay, Jason, one.
Okay. So there are some changes to metric names between Solr 9 and Solr 10. Is there anything to help users map those so that they know how to update their dashboard?
So so one thing that the original contribution I did to 9.7 to go to Prometheus, I didn't put descriptions. This one has descriptions on every metric. So if you hit that metric point, we'll know exactly, it tells you this is what that metric does and this is the type, whatever. Because when I was going through it, I didn't know what these metrics. So when we did this migration, you have to figure out what the metric, and we wrote it out. So you don't have to just document it. You can just hit the endpoint and there's descriptions. What did this metric?
I think what Jason means is there a way to go from the old metric to the new one? Like what's the
just
mapping?
like,
Not what does the new one mean, but what was the old one that corresponds to this?
I was interested in both. I think they just helps the time.
Okay, yeah, that
But
would
if there's
probably
some
be.
mapping or tool.
Yeah, I don't think there's a one-to-one mapping. We could probably write something out because it's all the same, right? It's just different labels.
One idea might be to mention whatever the previous name was in the description.
Yeah.
They're already pretty long.
Well, but
But even the Grafana example dashboard that ships with the older Prometheus exporter,
Oh yeah.
updating that to the new one would give you that mapping.
Yes, actually, yeah, that's a good point. Yeah, we could create a new one and ship it.
That's an interesting idea.
I forgot that one existed actually.
We could do that.
Okay, we're out of time. Thank you so much.